Okay, welcome back everyone. In this example, we're going to look at how to calculate sound intensity and sound intensity level. So this is problem number 40 on page 500, and basically what we want to do in part A is think about what would happen to the sound intensity level, in other words the loudness, if the power of a source was doubled from 5 watts to 10 watts. And we have a couple of equations to guide us. First, we have the intensity equation, which is P over 4 pi r squared. And you might be tempted to say, well, if we're going to double the power, that's doubling the loudness. But the problem is that the loudness is the logarithmic equation, beta equals 10 log base 10 of I over I naught. And so it turns out that having double the power, which does mean double the intensity, is not going to come out to be double the decibels. And so it's actually going to be 1, that it increases but not double. Now, for a quick proof of this, what we do is we calculate the intensity and we plug it into the equation for loudness. So the intensity is the power, so 5 watts over 4 pi times 5 meters squared to start with. And I believe that this gives us something like, oh, I'm sorry, we're 10 meters away from the source. I'm sorry. So the distance or the radius remains a constant 10. And this gives us an intensity of 3.98 times 10 to the negative third watts per meter squared. Okay, so we plug that in and we have a loudness of 10 log base 10 of 3.98 times 10 to the negative third watts per meter squared over 1 times 10 to the negative 12 watts per meter squared. And so, like any self-respecting logarithm, the units cancel out, and this entire log term turns into about 9.6, because 10 to the negative third is about 9 orders of magnitude, or 9 factors of 10, larger than 10 to the negative 12. That's how the logarithm works. Another logarithmic scale is the Richter scale for earthquakes. But anyways, this gives us about 96.0 decibels. Okay, now, if we double the power to 10 watts, so if I put in 10 watts for this, same distance, that just means that the new intensity is 7.96 times 10 in the negative third watts per meter squared. Okay, and we take that and we plug that into a new calculation of the loudness. So 7.96 times 10 to the negative third over 1 times 10 to the negative 12th, watts per meter squared. And this time, for the entire log term, we don't get double 9.6. We get 9.9. So 10 times that, and this turns out to be 99 decibels. So what this says is that having twice the amount of power, in other words, the source is pumping out twice as much energy, does not double the loudness that we perceive. It only increases it by 3. Now, in a previous video, I talked about some earplugs that I had that decreased the loudness by 32 decibels. And so the question was, well, how much intensity is that? Okay, well, the way that we could set this up is that 32 decibels is the difference between the intensity without the earplugs and the intensity with the earplugs. Oh, wait, it's not intensity, it's loudness. And so what we'll do here is we will plug in the equation twice. So the problem is that I don't truly know the intensity of the sound, but I do know that the first fraction is going to be I1 over I naught, and then I'm going to subtract from that a second fraction of I2 over I naught. Alright, now something that you need to understand about logarithms is that when you subtract them, you actually end up dividing. But the thing that I can do first is divide everything by 10. That's cool. I can do that right away, and I'm going to have 3.2 is equal to the log base 10 of I1 over I0 minus the log base 10 of I2 over I0. And now this is where this weird thing comes into play, that the log of A minus the log of B is actually equal to the log of A over B. And I'm not going to prove that. I'm just asking you to believe me. You might have learned about it if you're that far in math. Otherwise, check out the appendix of your book. Okay, so this means that 3.2 is equal to the log base 10 of, now pay attention, I1 over I0 divided by I2 over I0. And so what this is going to tell us is that the I0s are going to cancel out, and 3.2 is equal to the log base 10 of I1 over I2. Okay, so this tells us that the starting intensity without the earplugs is going to be greater than the final intensity with the earplugs. Well, how much greater? In order to answer that, we want to actually solve this for the ratio I1 over I2. Now, if you remember that I was talking about x equals the log base 10 of y, that really means that 10 to the x equals y. Well, we can reverse that as well. And in order to undo the logarithm, I simply raise the side 10 to that power. So in other words, what I'm trying to say is if I do 10 to the 3.2 and 10 to the log base 10 of blah 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 blah, then I can cross all of that out. Okay? And the 10, the log of this is basically 10 to the 3.2, and when you calculate this, it turns out to be about 1600-ish. I'm rounding. Okay, so long story made longer, this tells us that the starting intensity was about 1600 times as big as the ending intensity. Okay, so when you wear earplugs that are reducing the loudness by 32 decibels, it's reducing the energy that arrives at your ears by a factor of 1600. So it's really quite sizable, and you youngins want to protect your hearing while you're young because you can't get it back. So that's it for this time. We'll see you next time.